Not that many levels left to go in the main campaign. I think the plan is do these two first. Dancing Machine planet names, then Waterworld, and the final thing is gonna be AI Showdown. We're gonna end with a bang. I do have a couple other things I intend to do before then, but for now I think let's proceed with some assembly challenges. So let's do these two. Dancing Machine. We all like the way Robot moves on the dance floor. That's why we want him to lead our dance team. Huh. Way to go, Robot. Way to go. The only problem is to make him come up with original dance sequences. How do you make creativity out of deterministic logic, you ask? I didn't ask that. I already believe all creativity comes of more or less deterministic laws of physics. So I have no problem with that. The answer is pseudo-random number generators. Okay, cool. PRNG. Continue. In this level, you only get one input. We call this the initial seed. The seed is put through the following steps to produce a pseudo-random number. In the algorithm below, shift left, shift left, shift right. Sure. Oh, and we're given an algorithm, which we just need to implement. Okay, that's no problem. That's not a challenge, really. This is completely trivial, a very simple algorithm. I guess let's implement this. I think I will still make an ASIC for this afterwards, so we'll see. Let me import leg.lml. There, standard library in place. Let's call this XOR shift.lml. Okay, so let's take a closer look. Now, I believe there's a bunch of different, not even a bunch, there's a million, I believe, pseudo-random generation algorithms with all sorts of different properties. And this I assume to be a very basic and very simple one, but I'm actually completely unaware of how, you know, of what properties there are. I have some understanding of the general approach. You just use weird math, like multiplying by prime numbers and stuff, and modular arithmetic. But other than that, yeah, I have no idea how these work. So, okay, temp 1 is based on seed, temp 2 is based on temp 1, and seed is based on temp 2. Okay, I don't actually need all the temps here, all these variables. I think I just need, like, really it would be 1 if I could do this in line. So in C I would just use 1 variable. But since I need to perform this into a separate register, I'm gonna need 2 registers, I believe. So okay, no problem. Let's say I have const. What do I call them? I don't want to call them seed and temp because they're gonna be, you know what? Yeah, I think previous and current are good choice. Right? So first what we do is we're gonna load our input into previous. This is gonna be our previous seed. And now what we're gonna do is we can take... Okay, I don't actually have shift left and shift right in my ALU, but like I've already deliberated a few times, I believe, I'm not gonna repeat myself too much, I can emulate them with div and mul, multiplication and division. So shift right is gonna be a division by 2. So what I need to do is I need to divide immediate 2, divide my seed by 2. And I'm gonna save it. I cannot override seed, so it's gonna be current. And now what I need to do is I need to XOR previous and current into current, right? I think that's right. Yeah, so now current. Yeah, cool. Next line. So we're gonna need shift left by 1 of our current. So what I do is I do multiply current by 2 and save it. I will need current, so I save it into previous. Okay, I don't like previous anymore, but whatever. Let's keep this for now. Right. So I have done the shift. Shift left is multiply by 2. So what I do now is I XOR, and again I XOR previous current, and it doesn't matter in what in what order I do an XOR, of course, and also I don't need to save either of them. Yeah, so I can just put this to current again. Okay, I like current better now. Right, so now final line, next seed. I need shift right by 2, which is gonna be divide by 4. So divide current by 4. Save it into previous. You know what? I kinda wanna do this is current. And now we have current, previous. Yeah, this looks better. Now it's all symmetrical. And finally, XOR previous current into current. And what I'm gonna need to do is I'm gonna need to move current into IO, except it's not mov, it's a mod by 4, right? So mod immediate 2 current mod 4, right? Yeah, and then I repeat. Okay, so label dance. And that's it, I think. Yeah, and my current, this was actually important because my current is now gonna be carried over to here. And unconditional jump to dance. I think that's it. Let's take a look. Oof, what? What is that? Why are you showing me this? I've never seen this before. Okay, whatever. Let's run. The robot is not doing anything. Oh, well, yeah, these are just rotational directions, right? Do I want to make the robot step a little bit? Because I expect... I think you can step here, right? Yeah. Yeah, you could step and you can actually do some nice dance moves. I don't want to do mod 4. I want to do like what's robot controls? Be right back. Okay. Yeah, so robot controls are mod 3 and mod 3 without chill. Commands mod 3, or actually with chill mod 4, we are doing mod 4. That would be sufficient to make the robot step sometimes, but it doesn't seem to actually be stepping. So let's run this again. Yeah, that sounds cool. It just does the left and right. Why am I getting passes on these? Because this tells me to do... See, like... This, I can't think with all that sound. These, explanatory bits, they're telling me that my output should be a 3 and a 1 sometimes. A 0, a 3. But I don't actually ever output that stuff. Mod 4. I don't actually output 1 ever, because it doesn't step. I don't understand. But if my algorithm was wrong, then we wouldn't have passed. Let's try mod 3 just to test. Yeah, see? What? This is super weird. Is this algorithm just... No, I don't understand. Okay, give me a moment. Wait. This doesn't even... This makes no sense whatsoever, because if I just press this, if I just press next, internal things happening inside of my computer with the output off, disabled, actually. Yeah, it is disabled. The thing still ticks. And the robot turns, even though I'm not giving it any directions. How is this even possible, and what huge thing am I missing? I was asked to output robot commands like normal, was I not? Output to move the robot. I don't understand. Yeah, no, I don't know. To me, this just looks like the level is broken or bugged or something. I don't understand any of this at all. Like, I even tried doing, you know, move step to IO. And it just doesn't happen. And instead the robot turns. And it doesn't matter what I really do. Like, move 1 to IO, it turns, move 2 to IO. Actually, it's gonna be sav to IO. Yeah, see? Now it just breaks, so that's not... Am I... Yeah, but mod 4 is correct. And it is in fact correct, that's what expected of me, but... Like... So 0 is gonna be turned left. So we expect the robot to turn to face this style. But it turns to face the other tile. It just keeps turning clockwise. Forever. And that's... Yeah, I think it might just be that this visualization is broken. It's a shame because I like these patterns and everything. Oh, there's even music. You can hear it. Yeah, and it changes. Yes, I recognize the melody, but I don't know what it's called, I'm afraid. I don't know my classical music. Yeah, it's a shame we don't get to see that or hear that. But, okay, so I'm gonna try to make an ASIC for this. I expect the ASIC to be completely trivial. I won't even bore you with it. But maybe the ASIC fixes it. So, be right back. Okay, I don't understand this at all. I'm very confused by this level. So, here's my circuit. It's quite simple, of course. You know, seed XOR seed shift right is this. Right, so we get our seed. XOR, this is a shift right, it's free. Next, the previous result, temp1, XOR itself shift left. So it's this, right? Shift left, XOR. And then we have shift right by 2. So 2 shift rights by 1. XOR. And that's our output, except mod 4, which this is a mod 4 as we know. And then next time I have a delay line, and we're gonna feed the output of the previous thing into here again, and we're gonna perform these 3 operations. But we don't even really get a chance to get to the second tick, because the first output already looks broken. So if I just run this, we get 29 as our input, but down below the explainer is telling me 56 XOR 28 equals 36, which the XOR is correct, but these numbers don't match what I actually get. I get a 29, and it's neither 56 nor 28. And I mean, from the fact that 28 is 56 shifted right by 2, I conclude that they expected the seed of 56, right? And then with the seed of 56, you get the output of 3. But that's just not what I get. And now if I output this, which is a 0, it just worked. It didn't before. It just started working when I started recording. Oh, and the robot started doing things. The robot started doing things. It just spontaneously fixed. It fixed itself. And the robot is doing things, but still, we still cannot quite hear the song or anything. Sometimes it does nothing, which is possible, I guess. Oh well, I've already spent way too long on this. I don't think I'm gonna try to optimize this any further. I think this is already pretty much perfect. I could try to reuse the singular XOR and use multiple ticks for a single computation. But no, I can't. You can't actually make me do that. So, yeah. This is gonna be my ASIC for this level. It's already ridiculously cheap, 98. It's very simple, so yeah, let's proceed with planet names. We had the intern type out planet names in human script. Unfortunately, he forgot to capitalize each name. I see. The inputs in this level represent the characters in a list of planet names encoded as ASCII. See the manual? Okay. New manual page. Each name is separated by a space, which has the numeric value 32. Replace the first letter in each word with its uppercase counterpart. The possible input characters are A to Z lowercase, space, apostrophe, and dash. Is that all? Wait, okay, but how do I... Oops. How do I replace a thing? Let's take a look at the manual, I guess. ASCII encoding. There we are. Okay, this simulator uses extended ASCII. I have no idea what extended ASCII is. In a few places below are the characters with their corresponding number. I wonder if this font is built into the game or if this is my font. I think it must be built in, right? Oh, text CP art. Apple. Wait. They change. Does this answer my question about the font? Is this just the font change? I mean, it is necessarily because we know that it's ASCII. Okay, console supports different versions of extended ASCII. Okay, so I think what I'm doing here is I am kind of writing I'm just typing the input into the output NU, so I will need to type out everything I see except the letters that need to be capitalized. So let's try typing a capital V just manually. It's a capital V, 86. So let's say sav. No, be right back. Standard library. Let's try typing out the capital V. So sav 86 into IO. I don't know. Did something good happen, or let's try sav 86 again. What? Yeah, let's try it. I don't actually know what I'm doing, but let's try to move from IO to, let's try to load. Input V, output V. Okay, so I kind of have to take the input. Okay, but this is pretty simple. I do not remember ASCII, of course, but I am pretty sure that capital and non-capital lowercase letters come at a constant offset. Yeah, so they come in alphabetical order if we take a look, right? A, B, C, D, E are adjacent, 65, 66, 67. And so are lowercase a, b, c, d, 97. So all we need to do to make a letter uppercase is we just add the offset, which is going to be what, 32? Yeah, so it's just plus 32. So let's just try this. Let's say const buffer. It's gonna be something. We're gonna be loading into buffer, and let's just say buffer add immediate, immediate to add to buffer 32. Save it to buffer, so this is capitalized, and move buffer to IO. And I expect this to, and let's also add the label. Labeled, I don't know, SED. Unconditional jump to SED. Let's see. Worked. Why? Input V. So I load it. Why is it 118? Oh no, that's correct. Yeah, V is 118. And then 118 plus 32 is gonna be 150. Oof, I may have... Oh, I need to sorry, I need to subtract. Okay, subtract 32. Yeah, V. Now we're gonna be outputting a capital O. Okay. So all we need to do now is we need to add an if for whether or not our letter is capital. I don't think I need to sanitize anything. I don't need to check for whether it's actually a letter or not. And I think it's fine if I just check if the letter is greater than or equal to 97. Right? So if, let's say, jump if less than or equals, why is LE not unsigned less than equals, right? If 97, immediate one, if 97 is less than or equal to what we loaded, this means that we are beyond the A, which means we're probably in the lowercase region. Although, yeah, we might have issues with... You know what? Yeah, this is probably not gonna work because, for example, what's a space? I don't remember what space is. I think they told me in the level log. Yeah, space, numeric value 32. Lowercase space, apostrophe, and dash. Right. Let's take a look at what apostrophe, dash, and space are. So space. Oh no. Where's apostrophe with dash? So is this apostrophe? I think that is. And do I even have any chance of finding? Oh, there it is, dash. Okay, so my naive check will not work. I mean, it was already clear it won't work with the space, but now it's abundantly clear. So what I actually need to do is I need to check for a strictly lowercase number. Okay. Okay. How do I do that most effectively? I think I just implement multiple jumps. So, yeah, I think that's fine. I think that's fine. What I can do is I can detect whether I'm outside of the lowercase place or the lowercase situation. So if I am less than, unsigned less than, if my number is less than 97, then I am not lowercase, right? Lowercase, I can't use that apparently. Let's say label lowercase. Okay. Not lowercase, right? And also, if I am immediate to jump, if I am unsigned less than, if where's x, y, z, so z is 122, right? So if 122 is below me, buffer, immediate one, then I'm also not lowercase. Otherwise, I am lowercase, and I need to do this, right? Yeah, so this is kind of a free or. That's cool. I like that. So if I am lowercase, I will need to do my offset thing, and then I jump, and then I'm done. So I think that's actually about it. No, it's not working. Let's see why. V, great. Oh. I didn't jump. Oh, I completely failed to... Oh, wow, I completely missed... It's not like I didn't think of it. I thought of it at first, and then I got so carried away with ASCII that I completely forgot about the words. I only need to capitalize the first letter. And this means I need to detect whether I am at the first letter in the first place. Okay. That shouldn't be a problem. But it's gonna complicate things, of course. Okay, give me a moment. Actually, I think this may have been completely unnecessary as well. Because I think what we're given is a completely lowercased string. This is not bad. Like this is good because it ensures we're not gonna break a string which has a capital letter, or rather we're not gonna try to unlowercase or to capitalize a non-letter. But still, this is probably not necessary. So, okay, let's see what we can do here. We're gonna need to keep track of whether or not we have seen a space. So, I think I might need a buffer for that. I think I might actually need a buffer for that. So, const, I don't know, space B. So, how is this gonna go? If buffer is space, then what I'm gonna do is I'm gonna say space equals true, but I don't need to do anything, so I jump to not lowercase. So let's rename not lowercase to, I don't know, ID, because we apply the identity function on our input. Nothing, or even actually pass is probably a more reasonable name for assembly. Right? We can pass. So space equals true, pass. Otherwise, what we're gonna be doing is, well, we're just not passing and we're doing this. But then I will need to reset. Well, just add here space equals false. Wait, no, this is not correct. This is not correct at all, because if buffer is space, I will need to pass regardless. So I don't need to capitalize pass at all. Right? If buffer is space, then space is true. And then I just jump to pass regardless. But now I need another if space yeah, then I jump over the jump to pass. Jump over to SED. Okay, something like this I can't actually, like, let's just try to write the sum of this. So if buffer space, oh, goodness, immediate to jump equals buffer 32, let's say, whatever, 32 it is. We're gonna be jumping where? This is, I mean, of course I could put a million jumps here. As always, I'm trying to minimize the amount of code I do. But oh well, let's just write something. So let's say if buffer is equal to 32, then I don't know, space scene, right? Label space scene. Where is this going to be? I think this is going to be above the pass at the end, right? So space scene right here, but above the pass. And what we're going to do, if we've seen space, we're going to save a 1 into space, right? So that's it. And we don't need to do anything else because we're just gonna fall through into a pass and we're good. But now on the next iteration, where it's not gonna be a space, presumably. And what we're gonna do is we're gonna be jumping if, I believe I don't need, actually, what's my, do I have a nice, because I implemented booleans, right? Remember, in my conditional block, I have booleans now. But what's a boolean? I think it's an or. A single boolean, right? I have boolean comparisons, or boolean operators, but since I need a single boolean, I'm gonna need to or a thing with itself, I think, or and a thing with itself. So let's say or b or for, or space, space, right? So we're gonna capitalize. Actually, no. If we haven't seen, so not. I want a not of space. But let's, instead of using, actually I can just do an and. So not. Do I have my not? Yeah, b not. I have b not. Perfect. B not. So if not space, then we pass. Right? We know that this is not to be capitalized. Otherwise, we can actually perform this entire routine, which I don't think I need this. So something like this might work, might not. Let's try. Broken. Oh, seriously? You're not giving me a space as a first? That's fine. I can just do save 1 into space. So we're gonna emulate seeing space at the beginning of the string. Oh, doesn't work. Why? What did I miss? So right now, space is... Oh, I forgot to reset space. Right. That's also okay, because at this point, right, if we are falling through, and we already know that we're not in space, we can save 0 to space, right? Should probably rename space into space scene, but let's see. V still broken. Why? Why not pass? Didn't pass. Wait a minute. I saved true to space. If not space, so false. Wait. Oh goodness, I don't have booleans in assembly. Confuse me so much. Give me a moment. Oh, right, no, of course, of course. My booleans are fine, my booleans are in order. But what I forgot to... what I forgot to escape is this thing. Right, we're gonna fall through. So we set, if we know that we need to do something, right? If we pass over this, we don't jump. We're gonna say false to space. Then we're gonna do something with our buffer. I don't know why there's a tab here. But then we're gonna fall through into setting space to true. And that's not what we want. So space scene, I might need to do something like jump, unconditional jump, to pass from here. Let's see if this works, and then maybe I can straighten my jumps. So V, pass, oh, perfect. Pass, 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 vocao. Now we see a space. Space seen, yes, set to true. Good. And out. But now space was seen. We do not pass. We reset space seen. Perfect. Katra kill kari vocao lematia. Arev katra killari. Vocao nirakt sansat. Katra bilak par talshaya. Karifar fularat sans at solak. Pilora plakto ketral takrerai. Takterai. Vsharta ruletek tokmar pilora kethera. Piloracularis. Somebody needs to clip that and put some demon summoning pictures for these sounds. Yeah. Grisumachna Kethera Shonhalok Plakto. Looks like it's working. It looks like it's working. Cool. This is going to be a challenging ASIC if I go for the ASIC on this, because this is very strange. This is an interesting control flow. Although, yeah, it's just a couple buffers. And I won't actually even need this buffer. I'll just need a buffer for space, and that'll just be a boolean. But okay, we don't need this, as we learned just now. Let me consider the possibility of cleaner jumps here. Okay, I think I see one way to cheat this slightly. Let's say this is sed.lml. Before I break everything, let's make a new one. So something I could do is, I don't want this mov at the end. I could put this mov at the start, and that way I won't need to jump to pass. It'll be enough to jump to SED. Which I think I'm not sure if that saves me any instructions, but that saves me a label, and I don't like labels. So let's try. I just do this, right? I move my previous buffer out at the start of the loop. However, this means that at the start we're gonna have issues. So what I can do instead is I can just move. Actually, you know what I can do? I can do something completely insane. I can do immediate to sub IO 32 to IO, because I know I need to capitalize the first letter always, and that's a single instruction, right? V. But then, unfortunately, I will have to load the next letter into the buffer, and unless my planet name is a single letter, I'm also fine skipping the second letter. So I can do mov IO to buffer, right? And then I can start my thing. So now I don't need to jump to pass ever. I just need to jump to SED. SED. Yeah, but so far I only added complexity. I only added a tick. And it's less robust. But I wonder if there's something else I could do here. Space to SED. Not sure. Okay, wait a minute. Why am I subtracting 32 in place if I can just spew out the buffer minus 32 into IO immediately? But that actually, again, that doesn't save me anything. It feels clever, but it's not useful. And I could, yeah, I don't know. Okay, another clever sounding idea, which probably doesn't lead anywhere, is I noticed that the space is also code 32. So something I could do is a thing where I subtract. Well, yeah, I cannot just subtract the previous letter from this one, because then I'm gonna subtract random values. But this kind of leads me to a realization that instead of doing these complicated jumps with space, scene, and pass and everything, which, by the way, I went back to the original program, something I could do is I could just control the number I subtract, and it's either gonna be 32 or 0 based on what I saw last. And that's actually probably gonna be easier, no? Like, if last time I saw a space set to 32, right? So like, instead of doing true and false here and there and everywhere, let's try this actually. So this, I'm gonna ditch that one. And something I can do is I can save 32 to space, right? Now, if I've seen a space, then, well, instead of save true to space, I'm gonna save 32. Yeah, see, it doesn't actually lead anywhere, because here I save 0, and now what I do is I just subtract space. Again, it kind of sounds clever, but it isn't. And it doesn't work because something broke it. I don't know what it is. Space, well, if be not pass. Oh, actually, yeah, I don't need this not anymore. But still broken. I'm not sure. Subtract buffer, space buffer, pass. I'm not sure. Space seen, then 32. Otherwise 0. Oh, and subtract. Wait. Okay, I think this is actually an interesting idea. I'm gonna implement this. Yeah, okay. Okay, I think this works. So I implemented that idea, and I think this code is simpler. This is easier to read. So every time I kind of trust the process, and at the start of the loop I load my buffer and I just spew it right out. I could even squish these into two separate, or into a single command, you know, subtract IO space IO, but I will need buffer later, so that's why I keep it. But really, this is self-contained, and this just trusts that the space will tell me whether or not I need to subtract. Or rather, the space will be the correct value that I need to subtract. And then I consider for the next loop whether or not I will need to subtract next time. So what I do is, this is literally an if-else construction, or construct, or whatever. I check if buffer is equal to 32. If it is, then I'm gonna save 32 to space, right? So if I saw a space, then next time I'm gonna need to subtract. Otherwise, this happens and we need to jump out. But I still think this is exactly the same number of instructions, I'm afraid. So how large is the program? 28? Well, the program is smaller, but I don't think it's more efficient. 4338 or 388? 4388 versus 4408. Okay, no, it looks like this is more efficient. I like it more. So this is cool. I would rename space. There. Now it's called offset. It's the thing we need to offset by. Okay. Do I do an ASIC for this? Of course I do. For a change, let's try doing it live. Let's see how well I fare. So I think this is gonna be a fairly simple, fairly standard ASIC. So what I'm gonna want is I'm gonna want a pulse, and I'm gonna want a simple thing like that. I am not yet sure if I'm gonna need many different kinds of ticks, but something I do need is I will need two different steps, right? I will need the step where I read letter, right? And I will need a step where I write letter. I don't think that's possible to do in this. Actually, it is. Yeah, so it's read-write. So it's literally going to just be take from 2. It's not even, it's a constantly powered. It's not even take from 2, it's... Wait. Oh, I don't... So, I don't even need a clock, do I? I actually don't need the clock. It's gonna be straight from the input to the output. Okay, okay, that's also fine. But of course, what actually happens between the input and output will be determined by the circuit, but that's fine. Okay, so first of all, we're gonna need to be able to add 32. Looks like it's time for a constant adder. Be right back. There. Subtract 32. So we're gonna be able to subtract 32 from anything we want. But we're gonna need to decide whether or not we actually want to subtract 32. But let's just check that this works. Let's put some ones here and there, and let's see. Oh, okay. Now, what we're gonna need to do is we're going to need a mux on the output, I believe. Yeah, and we're gonna need to decide whether or not we want the changed or the unchanged version of the number, right? So it's literally just this. And now all we'll need to do is we'll need to decide. Let me set this like so. So this guy will need to decide whether or not last time we were a space, which should be very simple. Equal to... Okay, I don't think I've ever done constant equals. But for now, let's just say... Do I have an equal? Yeah, I have an equal. Let's just use a equal with a const. Let's not reduce this for now. So equal to 32, right? We're gonna want this, we're gonna want this. And I think it's literally just a 1-bit delay line over here. Like so. And that's it. Oh, except... Ha. I might need a pulse. I might need a pulse for the first one. Yeah, I think I need a pulse for the first one. So let's use my A6. Let's have a pulse with an OR. Or give me an OR. Goodness again. There it is. Whatever. Something like this. Let's see if this works. Vocal are. There we go. Great success. Okay, let me clean this up slightly. Just like that for now. And let's consider equal to 32. I'm pretty sure I should be able to reduce this equality by a lot. Yeah. Actually, all I need to do is I need to check for that particular bit pattern. Which, okay, let's see. I think a manual approach might be best here, actually. So 32 is just gonna be one of these bits. All right, so what I need is I will need some ORs to check all the pins, right? So I check these ones. Just about doesn't work. Can I see the number of ORs doesn't line up? I will need one or too many. I don't want this one. But let's Actually, let's say it's a NOR. Right, so I need all these to be off. All these I need to be off. But I also need this one to be off. Oh, yeah, not a NOR. Yeah, see, that sucks. I need another OR here. And then... Right, and then an AND for this. Like so. So this is equal to 32, I think. Right? Yeah, I think this is correct. So this is EQ32. I'm not sure if I could do that more efficiently. And also, I don't think I'm gonna hard-code it as an actual component. What is this OR doing? Oh. And then, like so. Yeah? Does this look okay? Yeah, I think this is right. Success. Okay, saved a bit on the ORs. Our gate score is now 41. The overall score is 92. Yeah, so a lot of these are much easier to solve without assembly. This was both faster and much cheaper. But, oh well. I did solve it with assembly, so I don't feel like I'm cheating too much. I really dislike these equals to 0 or equals to constant setups. Could I improve it somehow? Nah, I think that's about it. Don't think you can do any better than that. I'm not gonna make a custom component for equals 32. So that's it. That's me. 131, 92. I do intend to get back to these.